Hello students. In this, the first of the recordings for Lab 2, we're going to be going over the analyses described in the Lab 2 Part 1 notes, so it might be helpful to have those in front of you. You are required to read those notes before you watch this recording. So in those notes, the goal is to take these sore throat data, very simple, obviously made-up data set, 8 children, we have data on their ages, whether or not they attended daycare, and whether or not they had sore throats at the time of the study. We'd like to put these data into SAS and perform a simple descriptive statistical analysis. So let's go ahead and think about how we do that. I already started my SAS session, and I've got the SAS program demo 1 that is in those notes, already copied and pasted in. So let's go ahead and explain the different parts of the SAS program first, and then we'll finally run it and see what we get. In this program, if you allow me to put some extra lines in here, we have a comment to begin the program right here. I've highlighted it. I'll unhighlight it. You can see that it's in green. SAS's program editor tries to color code various parts of your SAS program, and basically when something's in green, using the default coloring scheme at least, that means it's a comment. Comments are good to put in your programs. They help with readability. Somebody else picks up your program, tries to figure out what's going on. Your comments can help to inform them. A comment begins with an asterisk. And you can see I have an asterisk as the very first character here in my code. And the comment ends with a semicolon. You can see that this comment covers several lines, and I've got lots of stuff in it, lots of asterisks. In fact, it's really only the first asterisk that is important to SAS, and the semicolon is important because that marks the end of the comment. Why'd I put all the other asterisks in? Because it looks pretty, and because it's just a nice way to highlight a multi-line comment. Okay, you can type anything else you want in that comment. SAS ignores the comment, basically. And it moves on to the next portion of the program, which is called a data step. Now, not all programs, but most programs that we will be working with will have a data step. Okay, and I'm trying to highlight it here. Hold on one second. Here's the data step, right here. So what is the data step? It's a series of statements where you create or modify a SAS data set. A data step will begin with the data statement, highlighted right here. The data statement begins with the keyword data, and then after that you name the data set that you're going to be working with. There are a couple of parts to the name. First, you identify the library that the data set will belong to. In our case, the library is called work. And then you type in a period, and then you type in the actual name of the data set after the period. All right, so work.lab2_sore throat is the full specification of the data set. What's this library stuff you're wondering about? What does that work library mean? Well, just think of libraries as locations on your computer where the data set will exist. And we're going to learn a lot more about libraries later on. Okay, work actually turns out to be a temporary library. The dataset lab2_sore_throat will exist in that work library somewhere on your computer while the SAS session runs, and it'll actually disappear from that location on your computer when you end this particular SAS session. It's a temporary library, this work library. Again, much more to come on libraries, both later in this lab and throughout the semester. All right, after the data statement, and it looks like some of my spacing is messed up here compared to the printed notes, probably because I cut and pasted this program in from the printed notes. Let me clean up the spacing here. All right, there you go. After the data statement, oh, did you notice that the data statement ends with a semicolon? Now, semicolons are very important in SAS, if you haven't already figured that out, because semicolons mark the end of the current statement, and they're an indication to SAS that it could look for a new statement next. There might be another statement starting. There is another statement starting after the data statement. It's the input statement. Now our goal here is to actually type the data directly into the SAS program editor. We're not importing from Excel like we did in Lab 1. So if you're going to be typing data directly into the SAS program editor, then one of the things you need is an input statement, because in the input statement you actually name the variables that you're going to input data values for: subject, age, daycare, and sore_throat. These are the same variable names. If I go back to the Word document, these are the same variable names that were in the heading of the table where we showed you the data in the notes. Okay, you can make up any SAS variable names you want, subject to a couple of rules. First of all, the names must be no more than 32 characters in length. Next, each name, the names cannot begin with a number. They have to begin with either a letter or an underscore. Underscores are allowed. Okay, so just don't begin a name with a number. After you've begun the name, after that first character, you can have any combination of letters and numbers. You can even have underscores in the names. You can't have any other funny characters in the names. No other punctuation allowed in the names, and no spaces in names. That's why the variable sore throat is sore_throat, not sore space throat. No spaces in variable names. Okay. I know you're all wondering, what are these dollar signs? Is that part of the variable name for a subject? Is that part of the variable name for daycare? The dollar sign is not part of the variable name. The dollar sign is actually an instruction to SAS. That instruction tells SAS that the variable subject, the variable that came just before this first dollar sign, that's a character variable rather than a numeric variable. If SAS does not see a dollar sign after a variable name in the input statement, it's going to assume that the values that you're going to type in for that variable will be just numbers. It'll get mad at you if in fact you try to type something else in, and it'll give you an error message saying, hey, wrong data, invalid data type, or something like that. All right, great. So since subject is a character variable, it's, the subject IDs are C, E, F, G, A, etc. You've got to have a dollar sign after the name subject, after the variable name subject in the input statement. This is the only place you need the dollar sign after subject, by the way. You don't use the dollar sign anymore later on in the code. All right, how about age? Okay, that's the next variable that we're going to type in data for. Then we've got daycare, which is also a character variable, so it's got a dollar sign after the name daycare in the input statement, and then the sore throat comes last. It's the order in which you list these variables is important. This is the order in which SAS will expect you to type in the data values in a couple of lines. Input statement, got to have that if you're typing the data directly into this program editor window. And notice that the input statement ends with a semicolon like every SAS statement. Next comes the data line statement. This is a short and sweet statement. This simply tells SAS that after this statement, SAS can expect to see data values for each of the variables listed in the input statement. All right, so data lines, and of course a semicolon. Then you begin with the lines of data. If you compare the data I've typed in here, they are identical to the data in the table on the first page of the Lab 2 Part 1 notes. Identical. The case matters here. Did I mention that in other SAS statements, case does not matter? I know we've done things like data is uppercase and work is lowercase. Actually, SAS doesn't care about the case in any of those SAS statements that we've already discussed. We've simply used different cases here for just to have a particular format to write our programs up. And we like to have SAS keywords like data and input and data lines. We like to have those in uppercase. And then anything that's not uppercase, well, that's either a data set name or it's a variable name. So it's something that's sort of created by the user rather than being a SAS keyword. All right, so usually SAS doesn't care about case, is what I was pointing out, except when you're typing in data values, it cares very much about case. Okay, so you've got to be careful. For example, when I type in YES here for indicating that yes, that first child, child C, did attend daycare, I've got to, that's a lowercase YES. SAS would regard it as a completely different data value if there was an uppercase Y followed by a lowercase ES, or any other combination of upper and lowercase. SAS would have thought was a totally different data value than lowercase YES. Be careful about that. That's not just SAS. That's pretty typical of all programming languages. Case matters in data values. Okay. Great. After you're done typing the last line of data, notice I have 8 lines of data, one corresponding to each child. That's sort of the typical way to enter data, although there are other ways to type data in. Notice that after I've typed in that last 8th line of data, I've got a semicolon by itself on the next line. That lone semicolon indicates to SAS that I'm done entering data, that the last line of data has already been presented to SAS. Okay. Oh, I forgot to mention one other thing about the data values that we were typing in. Notice that there's a blank space between each data value in each line. C, and then that's followed by 3 after a space, and then that's followed by YES, but after a space. Why is that important? Well, one, for readability. Certainly, it's nice to have the values separated by spaces so you can tell them apart. And also, the way I've decided to create data, this is called free format input. You can basically put the data values anywhere on a line as long as each pair of data values is separated by a space. Otherwise, SAS wouldn't be able to tell the C and the 3 apart if they were right next to each other, at least not with the way I've currently, not with the information I've currently given SAS. Right, so I have to have a blank space between the C and the 3. You know, I need to have a blank space between the yes and the no in that first line. Otherwise, SAS would think yes, no is one long data value. Just think about what SAS, what the computer would be thinking to itself while it reads the data values, and I think that space will make sense to you. You can have more than one space in between the data values if you want, but I didn't see the need for that. I think the data values are pretty readable, and SAS will have no problem with them either. All right, the end of the data step. Remember, we were working on the data step. That's the set of statements where we tell SAS about the data, where we read in, create or modify a data set. The last statement in that SAS data set is the run statement. This is actually an optional statement. I don't know if you knew that from the last lab, but it's an optional statement, but it's usually good practice to put it in. Okay, putting in run statements will allow us to do things like highlight and run just parts of our code. Often we like to do that. If you don't put run statements in sort of in the middle of your program, then you have to run the entire block of code to get SAS to produce anything. Okay, that's the data step, and I think I'm going to end this particular part of the recording, and in the next recording I'll go on and I'll talk about the procedure step that follows.